Right, so now let's look at an example involving polar coordinates. Right, so we are asked in this example to sketch the curve given by the following equation. R is equal to sine theta. Right, so this is a polar curve. Right, which means it's a curve whose equation is given in terms of polar coordinates. And we have to sketch it on the xy plane. Right. We're not going to sketch it on the r theta plane. Right? We're going to sketch it on the xy plane because it's a polar curve. R and theta here represents the polar coordinates for points. Right. So we're sketching the curve r equals sine theta for theta between pi over 2 and pi. Right. Now, our strategy here is to try and convert this equation into a Cartesian equation. In other words, an equation in terms of x and y. Right. How do we do that? Well, we have some equations that tell us how x, y, and r theta are related. Right? We have x is r cos theta, y is r sine theta, and r squared is x squared plus y squared. Right? So what we have to do is we have to look for terms of this form, r cos theta, r sine theta, or r squared in our equation. Right. Now, as it stands, there are no such terms in our equation. Right. We have r is equal to sine theta. Right. Which just means we have to manipulate our equation a little so that we can get it into the right form. So how are we going to do that? Well, how about we multiply the whole equation throughout by r, right? So multiply by r, and then we'll get r squared is r sine theta. Right, and now we're in business, right? Because here we have r squared, which is x squared plus y squared, and then we have r sine theta, right? Which is y. So this equation can be written in terms of x and y as that. X squared plus y squared is equal to y. And so now I want to sketch the curve. Right, so we're not quite done. We need to get this into a form that we can sketch the curve. And what we're going to do is we're going to complete the square for y. Right. So let's go ahead and do that. Right. So we get x squared plus y squared minus y is 0. And then completing the square for y, right, we get x squared plus y minus a half squared equals 1 over 4. So that is now the equation for a circle. Right? And it's a circle with center at x equals 0, y equals a half, and the radius for the circle is a half. Right, that's the radius squared there, a quarter. So the radius is a half. Right, so now let's sketch this curve. Right, so our center is there, y equals a half. Right, the radius is a half, so we'll go up to 1. Okay, so now let's sketch it. We'll try to sketch it. And there's half. Right, not an exceptionally good circle, but it'll do. Right, so right, there's a turning point there, and the turning point there. Right. Now, we have bounds for theta. Theta between pi over 2 and pi. Right. So here's theta equals 0. Right. Positive x-axis. Theta equals pi over 2. Over there. And down here, we have theta equals pi. And so we're only interested in what happens when theta is between pi over 2 and pi. Right? Which means, right, theta equals 0, pi over 2. We're not interested in this bit. Right? Right, so that is not the part of the curve we're looking for. Right. So the curve we're looking for is actually just a half circle. Right. Now, if we hadn't put up this restriction, if we had allowed theta from 0 to pi, we would have gotten the whole circle. Right, because we're only looking for theta between pi over 2 and pi, we only get half the circle. Right, so it's important that you indicate, the center of the circle over there, right? The turning points over there and over there. Right. Right, so this is a typical kind of example of sketching a polar curve. Right? We will always have equations where we can reduce it to a Cartesian equation and sketch the curve from that.